In this lesson, we will begin discussing Module 1, and the sections that we will cover are sections 1.3 and 3.1. This section deals with linear functions. And if we look at the name or the word linear, we see the word line in that word. Therefore, these functions will all have graphs that are lines. If you will recall, the equation of a linear function is f of x equals mx plus b, where m stands for our slope and b stands for the y-intercept of the line on the graph. If you will remember, all y-intercepts have the form 0 for the x value, and then whatever the y-intercept is the y value of the point. So let's take this equation, f of x equals mx plus b, and see if we can work in an example. And the example here is find the slope and the y-intercept of the line 3x plus 4y equals 12 and graph. Now you'll notice that our equation is not in the form f of x equals mx plus b. So in order to find our slope and our y-intercept, we need to do some algebra using order of operations to solve this equation for y. The reason we solve it for y is because y and f of x are the same thing when you're talking about functions. So I'm going to begin by taking my equation, 3x plus 4y equals 12. And if I'm solving for y, I'm going to leave the y term alone, and I'm going to subtract 3x from both sides. That gives me 4y equals, now I want to put the x term first as it is in the equation of the line. So I will write negative 3x plus 12. Now we're still solving for y, and so I need to divide each term through by 4. When I do that, I get y equals negative 3/4 x plus 12 divided by 4 is 3. So my slope is negative 3/4. It's the coefficient of the x term. And my y-intercept is the point 0, 3. So I will begin by graphing my y-intercept, 0, 3, and then I will use the slope to find a second point on the line. So my second point on the line, I will go down 3 because the slope is negative, and 4 to the right. 1, 2, 3 down, and 4 to the right, and make a second point. And then at that point, you'll take a straight edge and you will connect the points. And we now have the equation graphed as a line. Now you will notice this line slants from left to right, going down. All lines of that direction have a negative slope, and we call those decreasing functions. If a line rises as you go from left to right, that indicates a positive slope, and we have an increasing function. If our line is horizontal, then we have a slope of 0, and this is called a constant function. So if we have a linear function, it will follow one of these three shapes: decreasing, increasing, or constant. Okay, let's move on and talk about slope a little bit more. Now you will recall that slope is rise over run. Rise over run is the slope, and if we are given 2 points, x sub 1, y sub 1, and x sub 2, y sub 2, our equation for a slope would be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. The direction in which we subtract our y's and our x's does not matter, so we could have written it as y sub 1 minus y sub 2 over x sub 1 minus x sub 2. Sometimes we, as we get into calculus, use the Greek letter delta. That's just a triangle. It stands for delta. And so we would write slope as delta y over delta x. And the delta stands for change in. So change in y, the difference, over the change in x, the difference. We also need to remember, as we continue on, that slope is also referred to as the average rate of change. So let's take another example and talk about it. This is h of x equals minus 3x plus 2. Now we can tell that this is in the form that it's supposed to be in order to determine the slope and the y-intercept. So our slope is negative 3 over 1, and our y-intercept is the b, which is 2, or 0, 2. Our average rate of change is the same thing as the slope, so that is negative 3. And we want to know if this is increasing, decreasing, or constant. Well, since my slope is negative, I know that this is a decreasing function. And if we graph this, we will start with the y-intercept, which is 2. And the slope is negative 3 over 1. So I will go down 3 and 1 to the right. And if I connect those 2 points, I have a graph of the line, which is a graph of the function.